Gemini 2.0, Google's latest AI breakthrough, is a revolutionary multimodal model that can understand and interact with various types of information, including text, images, audio, and video. This next generation AI allows users to have dynamic conversations, not just through text, but also via voice, offering a range of languages and accents. With its impressive content creation capabilities, Gemini 2.0 can generate blog posts with accompanying visuals or edit images based on simple prompts. Its real-time interaction features, like the Multimodal Live API, enable seamless audio and video conversations with instant feedback and spatial reasoning abilities, allowing it to analyze photos, videos, and even 3D models. The model's speed and efficiency, powered by the new Flash model, make it ideal for tasks like coding assistance, real-time feedback, and using Google Search for the most accurate and up-to-date information. Whether you're a developer, student, or AI enthusiast, Gemini 2.0 offers a versatile toolset, pushing the boundaries of what's possible with artificial intelligence. We will run Gemini 2.0 on our local machine, focusing on scenarios such as the local Multimodal Live API, video analyzer, and research assistance. Let's begin with the Multimodal Live API by downloading React.js from GitHub. The Multimodal Live API enables developers to create real-time multimodal applications powered by Gemini 2.0 Flash. This demo features an open-source React.js boilerplate, available in the link below, designed to help web developers quickly start building their own real-time applications. First, obtain the API key from Google AI Studio. Once the key is generated, launch the React.js boilerplate in Visual Studio Code. Next, open the .env file and replace the placeholder with your API key. Then, in your terminal window, run npm install to install all the required packages. Once the installation is complete, start your application by running npm start. As you can see, the Multimodal Live API is now up and running. Let's begin by exploring the screen sharing feature. I will click on Screen Share and select my desired screen. Then I will ask the prompt, "What do you see on my screen?"
I see a screen that shows a code editor, likely Visual Studio Code, with a file tree on the left and a code file open on the right. There's also a terminal window at the bottom.
Next, I will prompt with, "I've downloaded the NextJS app from GitHub. Could you help me get it running?"
Okay, it appears that you have a Next.js app. To run it, you will first need to make sure you have Node.js installed. Then you will need to navigate to the folder where the code is and use a package manager like npm or yarn to install the dependencies. And finally, to start the development server. Do you need help with any of the steps?
Yes, I will start by running npm install first.
Sure, after running npm install, you can try running --npm run dev to start the development server. That command should start the application, and you will be able to see it running in your web browser.
I'm encountering the following error. Could you help me resolve it?
Yes, I can see that you are getting an error. The error message, npmerr, could not read package.json, indicates that the package.json file, which is required for npm to install dependencies, is not present in the current directory, or there is an issue with its accessibility. Double check that you are in the right folder and that the package JSON file exists there. If the file does exist, then please check the permissions or verify it isn't corrupted.
All right, I've installed all the packages. What should I do next?
Now that you have successfully installed the dependencies, you can try running --npm run dev in the terminal. This will start the development server and allow you to view your application in your web browser.
All right, what do you see now?
I see that the application has started successfully on http://localhost port.
Next, I will test it with the webcam to see how it performs. How many fingers do you
I can
see?
see one finger now. Now I see two fingers. I see 5 fingers now.
What am I holding in my hand?
You are holding a black smartphone.
Can you describe the room?
The room appears to have light gray walls with a framed picture on one of them. There's a green curtain to the left, and a door can be seen on the right. There also seems to be a table in the lower center of the room.
Now, we will move on to the video analyzer demo. The architecture of our NextJS application is structured as follows. The application architecture supports both the video analyzer and research chat functionalities. Users interact with a Material UI-based interface in the browser, which communicates with the NextJS server. The server handles routes for rendering the UI and API requests, such as those for the video analyzer and research chat. It securely connects to the Google Gemini 2.0 API using an API key stored in environment variables. Processed responses are returned to the client with real-time updates enabled through WebSocket/HTTP communication. The API handles video analysis using Google's Gemini 2.0. When a video is uploaded, it is temporarily stored on the server before being sent to Gemini's Video Analysis API for processing. Key information is extracted from the video and returned as structured data. This data is formatted and displayed on the user interface. The process is secured with API keys and supports multiple video formats. Let's run it and see how Gemini 2.0 analyzes the video. We will upload a sample video showing a person walking towards a car in a yard at night and submit it to Gemini 2.0 for analysis. As seen in the video clip, the scene features a person walking towards a car in a yard at night. The Gemini 2.0 response analyzes the video, identifying the main subject as a person walking towards a car in a yard at night. Key events include the person appearing in the yard and walking toward the car. The overall summary succinctly captures the scene, providing a clear and structured description for easy understanding and analysis. Next, we will review the Research API. Powered by Google's Gemini 2.0, it functions as an AI research assistant capable of analyzing academic content and summarizing research papers. The API maintains context through chat sessions, allowing follow-up questions on the same topic. It processes queries to extract and summarize specific sections, such as methodology and findings, with academic accuracy. Responses are provided in a conversational format, and the system ensures security with API keys, while supporting comprehensive research analysis. Let's run the demo by providing a Microsoft research paper on the latest 5.4 model. Once the paper is pasted into the UI, we'll review the Gemini 2.0 response to see how it analyzes and summarizes the content. As you can see, Gemini returns the following research response. The 5.4 language model utilizes high-quality synthetic data and advanced post-training techniques like PTS and DPO, excelling in reasoning tasks and outperforming larger models such as Llama 3. While efficient and aligned with responsible AI principles, it has some limitations, including factual inaccuracies, challenges with instruction following, and size constraints. Next, we will proceed with follow-up questions to further explore the research content. As demonstrated, Gemini effectively maintains the entire chat history, preserving the original context of the conversation. This ensures that responses are not only relevant to the new questions, but also seamlessly tied to the prior exchanges. By retaining the thread of the discussion, Gemini allows for deeper exploration of complex topics, enabling users to build on previous insights without needing to repeatedly restate the context or background. This capability makes it particularly useful for research tasks requiring iterative questioning and comprehensive analysis. Gemini 2.0 represents a significant milestone in AI development, promising to revolutionize how we interact with and utilize artificial intelligence. From its multimodal capabilities to its agentic behavior, this model is set to unlock new possibilities in AI-powered applications and services. As we look to the future, one thing is clear. Gemini 2.0 is ushering in a new era of AI that's more capable, more intuitive, and more integrated into our daily lives than ever before. Thank you for watching, and see you in the next one.